In this video, we are discussing function families, vocabulary, and key features. Throughout Algebra 1, you are going to learn more about these functions, their graphs and equations. You will be able to write equations. You'll be able to know why the numbers make the graph look the way it does. But for now, all I need you to do is recognize the shapes of the graphs and what the equation will have to make that shape. All right, so these are our 6 function families. These are our 6 function families. It is important to note that any given graph or equation will only fall under one of them. You cannot be in more than one function family. So to start, let's talk about linear. Linear literally says the word line. One line at a constant rate. So if your graph has one line, then it is linear. Pretty straightforward. You've seen this before in Math 7-8. In the equation, you will see something along the lines of y equaling mx plus b. 1x. X to the power of 1 makes one line. In a quadratic, you will see this shape called a parabola. It looks like a U. It can open downwards. It can open upwards. It can be on the axis. It can be off of the axis. We'll learn more about that later this year. For right now, you just need to know that if you see this U shape, this parabola, that it is quadratic. And in the equation, if you see x squared, the highest power being 2, that means the graph is quadratic, or a quantity squared. That means your graph will be quadratic. Similarly, this little John Travolta shape is called cubic. X cubed. We're really not learning those in Algebra 1, though. You just need to recognize them if you see one. Absolute value will be somewhere on the graph shaped like a V, either opening upwards, opening downwards. It can be on the axis, it can be off the axis. You just need to know that it'll be shaped like a V. And in the equation, you have these 2 straight line brackets. They're called absolute value brackets. You've learned them before, but we will review them at some point this year. For now, what you need to know is that absolute value is shaped like a V on the graph in some direction and somewhere, and will be formed by these brackets in the equation. Exponential. Exponential is characterized by having an x as the exponent. So if you see a number to the x power, the power of x, you know that equation is exponential. It will form a graph that's sort of a half U. It might increase, it might decrease. It might come from the bottom of the graph, start at negative infinity, but like upside down. As long as you're seeing a half U, that is exponential. Its direction, you will learn more about later this year. For now, exponential, x as the exponent, a little half U shape. Finally, we have piecewise. Piecewise is characterized by a graph that's broken into different pieces following their own rules. You will see an equation that has different rules set up. So these are what you're going to need to know, the key features and the shapes of the graph. There's also different features that we can, describe a graph with, such as increasing or decreasing or constant. You read a graph like you read a sentence, left to right, always. So you can increase from left to right going up, decrease going down, constant staying the same, no change. You can be discrete, where you will only see points on the graph. You can be continuous where there are infinitely many points because a line is drawn. That doesn't necessarily mean there are arrows on both ends, that it goes on forever. It just means that that line has infinitely many solutions on it. You can have an absolute maximum or maximum set of points as long as you have a max value. You can have a minimum or minimum set of values. Or you can have none. You can have straight lines or curves based on the shape of the graph and which function family you're in. And finally, the graphs can be considered linear. Nonlinear is everybody else. And symmetrical has some vertical line of symmetry.